Graph of the cosine function. Okay, we should be able to go through the cosine function a little more quickly. The cosine function is y equals cosine x, or in function notation, g of x equals cosine x. We already know that we should use those nice values from the unit circle. I've marked my quadrantal angles. The cosine function will tell us the a coordinate at each of these places. As far as filling in the table, let's use those nice numbers, 0, pi over 2, pi, etc. Okay, so for an input of 0, if I don't rotate at all, obviously the a coordinate is 1. If I rotate up to pi over 2, I'm at 0 for an a coordinate. Going all the way to pi brings me to -1. 3 pi over 2 back to 0, and finally all the way around, and I'm back to that 1. As far as drawing the graph, it looks like the scaling should be the same. I should count by 1/2 pi or pi over 2 on the x-axis and mark 1 and -1 on the y-axis. And then we can start plotting our points. It looks like 0 goes with 1, 0, 1. The a coordinate then goes down until it hits 0 at pi over 2. From there it goes into the negatives. By pi I'm at -1. 3 pi over 2 back up to 0, and then 2 pi is back up at 1. And then just like the sine function, we know that if I continue to rotate around the circle here, I'm just going to come across all those same a coordinates all over again. So this graph is just going to continue in this same pattern over and over and over and over. Let's see, if I rotated to -pi over 2, I'd be at 0, and so you can see on this side as well that same pattern continues. The cosine function is periodic, just like the sine function. Okay, here's a cleaned up picture of the cosine function. Let's list out some of the features. As far as domain, just like sine, this graph goes on and on forever in both directions, so the domain would be all real numbers. And the range, the y values, again, just like the sine function, the highest y value on here is 1. The lowest y value on here is -1, so same range as we had before. The period, the horizontal distance we have to travel before the graph repeats itself. Well, if you kind of think of this as the start, how far do I have to go before the pattern starts over again? Looks like it happens right here is when the whole thing is going to start repeating. So, once again, the period is 2 pi. How about symmetry? Well, we don't have the odd symmetry with this picture. If I turn the graph upside down, it does not end up being the same picture. So it's definitely not odd, but you can tell there is a symmetry here. We call this an even function, which means it's symmetrical across the y-axis. You could imagine folding the paper along the y-axis. The portion of the graph on the right would exactly land on the portion of the graph on the left. That's called being an even function. How about the midline, the line that cuts the graph in half, the horizontal line that cuts the graph in half? Well, once again, it's just the x-axis, which has equation y equals 0. The amplitude, vertical distance from the midline to the top, is once again 1. And then the 5 key points, those are the 5 points we had originally marked. They are all the spots where the graph either hits the midline or is at the high or low spot within one period. We can write down the coordinates. We have 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. And then the pattern this time for cosine goes high, middle, low, middle, high. Of course, all this information is important, but for now, the key takeaways would be the basic shape of the cosine function. Looks like this. Notice the rounding at the ends. It's rounded at the ends because we know it's going to continue on. We know that the period is 2 pi. we know that the high spot is 1. I like to call this picture the vase. Again, you can come up with another name if you want to, but remember that the cosine function is the vase, period of 2 pi, high spot of 1. Thanks for watching.